Every gardener knows the struggle of heavy, dense soil. You dig, you turn, you amend, and yet when it rains, the ground still puddles, and when it dries, it hardens like brick. But beneath the surface, there's an invisible army doing work no tool can match. They're smaller than dust particles, yet they perform a task even the strongest tiller fails to achieve. They drill tunnels through solid earth. These tiny soil engineers are microbes, and understanding how they function can completely change the way you build and manage your soil. What we'll cover today is how microbes, physically and chemically, open up compacted soil, how to feed and sustain them, and how to harness their natural drilling power to turn dense ground into living, breathable earth. Well, the foundation of living soil begins with microbial tunneling. Soil structure isn't just about mineral particles, it's about the spaces between them, you know. In heavy clay or compacted ground, those spaces are crushed or sealed, making it impossible for water or air to move freely. Plants suffocate not because the minerals are wrong, but because the soil has lost its architecture. Microbes are the first step in rebuilding that architecture. Specifically, bacteria and fungi create microchannels, spaces often just a few microns wide, that link up into complex networks. These networks transport oxygen, water and nutrients, allowing plant roots and worms to follow the same paths. Over time, microbial tunneling transforms hardpan into friable, root-friendly soil without ever lifting a shovel. The phrase "microbes drilling tunnels" isn't poetic, it's literal. Soil microbes create movement in two primary ways: by breaking down mineral bonds and by producing polysaccharide slime that binds particles together into crumbs. When bacteria feed on organic matter, they release acids and enzymes that gently dissolve mineral surfaces. In heavy clay, this chemical action weakens bonds between plate-like particles, allowing them to separate. Fungi, especially mycorrhizal species, extend hyphae, microscopic root-like filaments, through these loosened gaps. Each hyphal strand pushes forward, exuding a sticky substance called glomalin, which acts like natural glue, holding soil crumbs together while leaving open pores in between. That's the drilling effect. Billions of bacterial cells and fungal threads work simultaneously, gradually forming microaggregates that evolve into stable structure. Microbes can't do their job if they don't have a steady source of energy. Their main fuel is carbon, and not all forms are equal. Fast-decaying materials, such as green grass or kitchen waste, create a real spike in microbial activity, but honestly, it's pretty short-lived. For sustained tunneling, what you really need are those slow, steady carbon sources that decompose over months, not just days. In practice, the most effective carbon-to-nitrogen ratio for microbial activity in dense soil is about 25:1, up to 30:1. You can achieve that, actually, by combining equal parts high-nitrogen materials, like composted manure or green leaves, with carbon-heavy materials such as shredded paper, straw or dried leaves. For example, when you're improving a 4 by 8 foot bed with clay-heavy soil, just spread a 2-inch layer of composted manure and a 2-inch layer of shredded straw or leaf mould, then water deeply to get that microbial feeding going. Within weeks, microbes will start breaking down the straw, binding soil particles and forming the very first microtunnels. While bacteria initiate the first stage of soil loosening, it's the fungi that really take the spotlight as the master builders, keeping those tunnels open over time. Mycorrhizal fungi, for instance, can extend several meters beyond plant roots, weaving a living web through compact soil. Quite fascinating, isn't it? Now, in practical terms, introducing fungal inoculants or encouraging natural fungal growth can really speed up the drilling process dramatically. You can do this by applying 1 part fungal-rich compost made from woody materials for every 3 parts regular compost in your topsoil mix. It's a simple yet effective method. Alternatively, if you're working on larger garden beds, you might consider mixing 2 litres of fungal compost tea into 10 litres of water. Then apply it evenly across 10 square metres. This jump-starts fungal colonisation, especially when followed with mulch to maintain moisture. It's a surefire way to give your garden a healthy boost. The fungi's glomalin secretion, often called soil glue, is what locks the structure into place. It's hydrophobic, meaning it resists waterlogging, while maintaining open pores for air exchange. Earthworms and microbes work in tandem to expand those tunnels. The relationship is synergistic. Microbes pre-digest organic material, making it palatable for worms, while worms distribute microbial colonies deeper into the ground. In dense or compacted soils, you can accelerate this process by feeding both microbes and worms together. A reliable ratio is 1 part worm castings to 3 parts compost, mixed into the top 4 inches of soil. After applying this mix, cover the soil with a 1-inch layer of mulch, leaves, straw or composted bark, and, keep it evenly moist. Within a month, you'll find small pinhole-sized entrances across the surface. Visible proof that microbes and worms are turning your soil into a living aeration system. Microbes can't drill through soil that's bone dry or flooded. Moisture and oxygen levels, they directly determine their activity rate. One practical way to maintain this balance is to water deeply once a week, then cover with organic mulch to reduce evaporation. Avoid compacting the surface by walking on garden beds. Even small pressure can collapse the pores microbes create. If your soil tends to crust after rain, you might want to try applying a thin layer of composted mulch mixed with biochar in a 5:1 ratio. 5 parts compost to 1 part biochar. The biochar acts as a stable home for microbial colonies, you see, and it helps keep those air channels open through all the wet and dry cycles. Unlike mechanical aeration, which is, only temporary, microbial tunnelling actually builds a self-sustaining structure. The tunnels they create don't collapse easily because, you see, they're reinforced with glomalin, humus, and stable organic complexes. Within a single growing season, you'll notice the difference. Roots penetrate deeper, the soil smells richer, and water no longer pools on the surface. What you're seeing is really the result of trillions of living organisms drilling, gluing and rebuilding your soil from the inside out. So, if your soil feels like concrete, don't fight it with machines. Feed it with life. Start adding slow carbon, fungal compost and moisture stability. If this guide helped you understand the living power of microbes, make sure to subscribe to Hydrohaven for more science-based, field-tested methods that work with nature's own engineers, and share this video with fellow growers who are done battling heavy ground the hard way. Let's spread the knowledge that living soil builds itself, one microtunnel at a time.